So the topic of today's presentation is 3D printer uses in astronomy. So I guess to start out first would be what are 3D printers? And so 3D printers basically could print out shapes, usually out of plastic, but really there are lots of materials. Mainly what I'll be talking today is 3D printers that use plastic. There's several types of 3D printers. There's some that you have a resin and it shoots UV light on in layers and slow, and then you get your shape your object that you want. And others, they just put layers of melted plastic on top of another layers of melted plastic. So, for example, here is a video of the one. I'll mostly be talking of the one that puts layers of melted plastic on top of other layers. And this is a quick video of one running in action. So I think it's sped up, but basically this is making a little figurine of Groot. So this is very sped up because this whole thing probably took several hours to do or to print. But it basically puts, one layer at a time. When you print something, you could configure how thick your layers are, and basically, the thinner the layers, the more detail you could get. But it takes longer. So. Yeah, there's lots of different kinds of plastic. So the different kinds of plastic have different attributes, and they melt at different temperatures. And so you could get printers that have like multiple extruders that can have different colors of plastic. So it could print the same. You could print. You could do. So here's a picture of my printer. It's not a very good picture, but the plastic I have is on a spool here, and yeah, so you could get different. You could use different types of plastic in that spool. You could have different colors, and you could get printers that have multiple nozzles, so you could do multiple plastics. Sort of without having to switch it back and forth all the time. But I don't know why you need multiple colors for astronomy.
Well,
but
no, you would not.
Yeah.
Because I've seen, demos or whatever, this type before. I haven't seen or heard of that UV that.
Oh, yeah. Right. So the question was, do I have a device that keeps the bed level? Yeah. So I do not, and I wish I had an auto leveling bed. So the printer I have is a pretty cheap one. I originally got it for I think $300, but I've put over $300 more into it. So my printer does not have an auto leveling bed. So every so often I level it myself. So on each corner of the bed, there's a knob with springs that you could adjust to change the height. And basically, I have the nozzle go to the reset position, and I move it around, and I make sure that it is the same height all around the whole thing. And it basically takes me an hour. It used to be that I had to level it every print, but with the changes I've made, I don't have to mess with it that often anymore. So some of the $300 that I put in, extra $300 I put into it, was I replaced the bed basically completely, because it originally came with a metal bed, and the metal was very thin and it warped. So there was actually no way that I could really level it with the knobs and the springs. So I replaced it with a thicker one. And I also have a glass top. So the glass top keeps it really flat too. So both of those things made it so I don't have to level it basically every print anymore. I'm printing on the glass. I actually put tape on the glass to make it stick better. Some plastics stick better to the glass, and some stick better to tape. Yeah, so a lot of the, when you first start 3D printing, a lot of people's first plastic will be a plastic called PLA. I believe it's made from some corn product. And it's a lot easier to 3D print with that, but it's not very durable. But I think, let's see, the one that sticks to glass, I believe, is the one that Legos is made out of. I forgot what that plastic is.
That'll last.
But the one that I like to use is PETG, and it's a similar plastic to what's used in like in drinking bottles, and it has a lot higher melting temperature. So when I was first doing in PLA, which is the plastic that beginners usually use, and that's actually really easy to work with, what happens is if you leave your part in the car or something, or leave it outside for a while, it'll end up warping. So if you use one of these higher temperature plastics, it'll last a long time, but it's harder to get your 3D printer to work with it. So and when I first started, I could never print in PETG because it would never work. I could only print in the PLA until I did all these changes to my printer. So one of these changes is that I built an enclosure to make sure that the temperatures were stable. So I actually have all sides. This enclosure is actually made from 2 IKEA side tables, and I 3D printed, right here, it's kind of hard to see, but I 3D printed little fixtures to keep the tables together. This is actually in my laundry room. And so this is two side tables stacked together and connected with the 3D print on each corner. And then I have some plastics on 4 sides. And then this is a shower curtain cut out that's on the front that I lower to keep the temperature stable in there. And then I just have the filament on top, and I have a hole through the middle of the table that the filament comes through and goes to the extruder. So yes, let's see. So I think, I think at for PETG, I think I do like 240 Celsius, something like that. For like PLA, I think you use like 190. You think that's high because it's in Celsius, but it still warps if you leave it in your car, the PLA. But also, I have this one has a heated bed to keep the plastic on. The heated bed is usually like 60 Celsius. Right, it's level to the nozzle. Yeah. Yep. I just level the whole thing anyway, just because sometimes it's easier. We start with a bubble level or something, but really just needs to be level to the nozzle in the bed. Yep. This one came complete. However, after all my changes, I had to take it apart. So I even replaced the firmware that it came with. The firmware didn't allow me to set the settings that I needed to get reliable prints. So the new firmware, I had to open it up and put an SD card in with the new firmware. And that let me calibrate the feed rate. What was really important was it let me calibrate the feed rate of the filament. Because the old firmware didn't let me do that. And so that really helped when I put in the new firmware. So the plastic I was talking about that could stick to the glass is ABS plastic. That's what they make Legos out of. So yeah, so you could do both. Yeah, you could do both, but I just put in the SD card. Yeah, you could get add-ons. You could like hook up to a computer and it'll feed it G code like directly from the computer. You could also get you could just get a small mini computer and do that. Some people like to do that because then they could have the 3D printer in their basement and then they could just connect to the computer from wherever they are and upload designs and have it automatically start. And you could even have it have a camera, and so you could look at it without having to go wherever the printer is. One problem I had is that the 3D printer is noisy, so when I had it like just across the room from my bedroom, it would like keep me up all the time because some of the prints take days. So that's why now it's in the laundry room. But yeah, so some people just hook a mini computer up to it so that they could just check on it without having to go up and downstairs or wherever it is. But I usually just put in an SD card. Yeah, so you could design your own objects, or there's also online, lots of people upload already pre-designed objects. I was going to go through some of the stuff that I designed, or even just, I was going to go through just some stuff that I printed, then I was going to show you some of the stuff I designed and maybe what software I use. And then I was going to show you some of the stuff that's available online to use. So some people do some really crazy stuff. But yeah, I would say like it's not just you buy a 3D printer and then download and go. You kind of have to learn how to do it, from what I've seen. Maybe if you buy like a really expensive one, it's ready to go more right away. But definitely like if you buy a $300 one, it's probably not just like ready to go. Oh yeah. Yeah, so that one, yeah, if you buy one and you have to put it together yourself, obviously it's not ready to go right away. Yeah, and also, yeah, so as you'll see, a lot of the stuff that makes it useful, it's not just the print by itself. You usually have to combine it with something else to make it useful. So I'll go through. Yeah, so I'll just go through some like astronomy items that I 3D printed. And then I'll go through like how you go about, one way at least, how you go about designing your own. And then I will show you other people's designs that are out there. And then if you have any other questions. So, okay, so one thing that's pretty easy to print are like dust caps. So I have a few, just like a 2-inch and a 1 1/4-inch dust cap. This is almost, you just print it and you're good. It doesn't really need anything else. You just, and then you could put it at the end of your telescope or whatever. I had a few scopes that were missing dust caps, so these were one of the first things I printed. I think this one I designed. This one I downloaded from another place. Both I couldn't just print it and then use it. It was just slightly too big. Like this 2-inch one was slightly too big to fit. I think it was just because the particular telescope I was putting it in it was just really tight to that 2-inch. Actually, when I tried to put this in another 2-inch, it was too small. So anyway, pass these around. I think both of these are in PLA, so these were when I was first trying to print. I wouldn't recommend this. I would probably, would want to reprint this in PETG so that it doesn't warp when it's in my car. So, okay. This next one is a Bonitov mask. I think that's how you say it. So this is really nice for focusing for like astrophotography or something. So I just put this in front of the telescope, and then you get a certain shape, and like when the crosses in the shape line up, then you know you're focused. So when I show you how I make designs, this one I actually used a generator that created an image for this where all these cutouts go, and then I used a 3D modeling program or a CAD program that I just traced the image at the right scale and created this one. This one's actually in PETG, so it's fine in the car. Oh yeah, and I just like glued felt on the inside. Yep. So this is like this one's just like, here's a finder dovetail holder. I wanted to be able to just use this finder on multiple different scopes, but I only had one adapter. And I actually had a really hard time finding where I could just buy these out of metal. So this one I didn't design, but someone else already designed it online, and I printed this. This is also in PETG, so it is good. And you'll notice here that like I have some hardware, so it's just a screw on here. One thing hardware with 3D prints I found is that you want to use stuff with you want to use big thread screws and stuff, because the thin ones it's really easy for those to not be very structurally sound. So anyway. Yeah, coarse thread and yeah, versus fine thread. So, yep. All the pink ones are the same PETG. Those black ones are the PLA. Yeah, I think this one's a PETG black one though. But yeah, those other ones are PLAs. So yeah, those black ones are not good in the car, but these red ones is PETG. I eventually, yeah, I don't know why I bought the red. I had some weird reason to buy the red, but now I just buy all black for astronomy stuff. Orange or red, yeah. It's supposed to be red, but it's sort of like pink too. I built Justin a finder holder out of the PLA too. That's why he has those pink rings or red rings. But yeah, so let's see. This one is like a camera holder, so you could put a Canon lens on here, and then on this side you could put in like just a 1 1/4 inch camera or an eyepiece or something. And so yeah, I basically you know, I bought this adapter, but I didn't have any way to mount it onto a mount that I wanted to use. So it's just like a 1/4 20. I just tapped the cord. I designed this little ring with this piece sticking out and a 1/4 20 tap in here, so that you could just yeah, put it on like a mount of some kind, a tracker or something, and go with that. So this was useful. Oh, again, this is PETG. Yeah, and I think StarSync Trackers has some pretty good ones.
Now this one that you got, did you get the directions of software and such downloaded, or did you have to do this?
That one I designed, yeah. So I didn't download that. I designed it and then printed it.
And would you call that a course through?
Yeah, I think that's coarse enough. Yeah, 1/4 20 seems to be like the really tiny ones, like I don't know. Oh yeah, I think that's a side effect.
Yeah, well, I think it'd be good.
So here's a solar filter holder, film holder. So it's actually two pieces then, and the two pieces sandwich the film on with, I think these are 1/4 20s also on here that just hold these together. And then I have some filter on the inside. And again, that just goes onto the scope like that, and then you take a picture of the sun or something. Yep. This is only partially astronomy related, but it's basically a Raspberry Pi with a high quality camera on it. So you could you know, connect it to a tracker and take some wide field images with it. But basically it's the case. I originally got the 3D printer to print electronic cases actually. And then later I was able to figure out more useful things to do with it. But this is a Raspberry Pi with a high quality camera with a lens on it, and has the high quality camera comes with this 1/4 20 hole that you could connect to a tracker also. So if you program your Raspberry Pi and then make a closure for it that holds the camera already nice and snug, put this on a tracker. Maybe when you set it up so when it's powered on, it automatically takes long exposure images. You could do some nice stuff with it. Anyway, this is only, I guess, partially astronomy related, but
the best part is
yeah, that's the new one. Yeah, it's nice because it has like a C mount or CS mount, or I think it has both actually. Yeah, and also yeah, and you can also get like a 1.25" connector on it, so you could put it in a telescope. And I think you could take up to like 180-second exposures. I think that's it. But the old cameras were limited to like 20 seconds. So this one is a 200 millimeter camera lens, and what this is so I could focus it with a motor. So I have a stepper motor here, and when it twists, it turns this pulley here that's connected with an XL belt, and the motor is stabilized with this metal piece that Gary made, which is connected to a non-rotating piece onto the camera lens. So basically, I could connect this to some electronics that I have. I have the electronics here, and I could focus in and out in small amounts without actually touching the lens. And there's actually software where it'll take a picture, download it, and then change the focus, take a picture again so that I could autofocus and get really good focus on stars without me even touching the lens. So I'll show later these. There's actually, what's really cool is that there's this program called OpenSCAD, where it's basically like you could write a program to make 3D shapes or 3D models. So what people have done is they wrote programs, and then there's variables that you can modify. And so you could take basically the program and modify those variables to get the parts that you want. And one of them is a pulley generator. So you could tell it, I want 20 teeth, and I want like the bore to be a certain size. And so all you gotta do is modify those variables, and you could get the part that you want. You will notice here that this pulley here is made out of metal. I found that if you don't have the middle stabilized, it's really hard to make these small pulleys and have it be stable. So I couldn't use small pulleys 3D printed, but it works really well when I make a pulley that something else is in the middle, and then you could just put set screws into the pulley, and it's pretty stable that way. So this is the same concept, except it's bigger on a refractor. Notice instead of that metal piece that Gary made that was on the lens, I have this plastic here that's holding the motor, and it's really thick so that it doesn't bend. So when I found, at least for PETG, if you want something to be stable, you gotta make it thick. If you need something to be thin, you gotta use metal. So, but this is the same idea, but it's the pulley is around the focus knob instead of the lens itself. And when the motor moves, it just moves the focus knob a little bit. And what's really cool also is that I just put a connector on here on these stepper motors, so I can use the same electronics end to do the telescope or the lens, and not have to have duplicate electronics. I just unattach it and attach the other one. Yeah, and here's the focuser box that I connect. There's the other end of that connector, so I could plug in. I could use the same electronics to connect the focuser of either that refractor or the lens. And I 3D printed the case that the electronics are in. This is basically just our Arduino with the Adafruit motor shield on it. And it's programmed to be a moonlight focuser. So it has a computer protocol about how to control a focuser, and that protocol is the moonlight focuser protocol. So even though it's custom electronics and hardware, the protocol is like what already a lot of programs know how to use. So yeah, when I'm talking, I can't hear the people online. Doug, did you have any comments or questions over all that?
Yeah, I did actually have one question that's more practical. Would it be possible to build something similar to the little focuser that would work on the back of one of the Meades?
Yes, it would be possible.
And would it be a kind of a similar sort of a thing? I would think maybe attaching it to the side of the tube or something like that.
Okay, so Doug's question was, can you make a focuser that attaches to the Meade's focus knobs, similar to how I did those lens and telescope focusers? And it would be possible to do that, but yeah, I thought that's the Meade focuser also has the lock. So if you had someone that went there and locked it, then you would also, if you're using it totally remote, then you would need also a control for the lock. That's why I thought, yeah. So you could do that, but if it's locked, then it won't work very well. But yes, you can.
Right. And would you need like separate ones? Because the Meade focuser's got like two parts to it, right? There's the outer part, the outer knob, and the inner knob.
Were you able to hear that, Doug?
Not really.
Okay, so I guess Gary's answer was good. I hate to repeat it because I can't repeat it the same. But next time I'll pass the microphone to someone who's replying. But basically, Gary said the Meade's focus is kind of stupid because when you lock it, it changes the focus anyway. And also there's mirror flop. When you mess with that focus, your field of view changes.
Right.
So that's why people get close to focus, lock it, then they use a separate focuser to really get fine-tuned focus. So while you could put a focusing thing on the Meade knob, usually you just you automate that microfocuser.
Okay.
You lock it down, and then you use the microfocuser to get the focus that you want. But if it's a dual-use scope where people are using it for visual, and that they use it for astrophotography, there's quite a big difference of focusing there. So you have to unlock it and focus whenever you switch out the whole thing. So that's quite complicated because if you want it to be all automated, you've got to have the camera on there in the first place. If the visual person didn't do that, didn't put that back on, then you got to unlock it and you got to do the coarse focus, and then you could use the microfocuser.
Okay. Yeah, well, at some point I'm kind of thinking about leaving my scope out there, which would have the camera mounted on it permanently. So that would probably be feasible.
Yes, if you have your own scope out there, then you could just leave your setup good and it'll be close to focus, and you could just use that microfocuser.
Okay.
Okay. Yeah, you shoot the visual observers. That's what Gary said. All right. Okay, so designing your own stuff. So what's nice about 3D printers is that you can make custom parts for your exact need, and you don't need to, have. I mean, that would also be nice to have your own machine shop to make your own parts, too. Yes, but what's nice is that for a lot of cases, you could just print your own parts that custom parts that you happen to need. So there's a lot of programs to do this for you, or to help make these parts. And I'm not going to say the way I do it is the best, but it's just the way that I've done it. So I use this program called FreeCAD, and it has a lot of options, I mainly use like the parametric modeling tool of FreeCAD. So if I just open one of my, so here's an example of the Bonatov mask that I made. So like I said earlier, I started with a generator, online generator, but it just basically printed me like a JPEG image. So it didn't have any thickness to it or any ledge to put on my scope. So, so when I made the 3D model, I started with the circle, and like I tell it how big to make the circle. Yeah. Anyway, and then I tell it to fill in the circle, and then I cut out from the circle, and this is where I traced the pattern of the image. So basically I made a bunch of shapes that are all the cuts that it's going to do, and I just tell it to cut all the way through the original thickness that I gave it. So, so you could see, like, I don't know, I made it like 5 millimeters or something like that, and then I make the cut, and then I made the shape, and basically I took that. I took the template and I traced all the cuts that I needed to, and then I told it to cut out of that, and then I gave it the ridge so that it could then here's the ridge, and I told it to go up so that it could I could attach it to the scope. So this program takes a long time to get used to, actually, but you eventually can make parts. There's a lot of other software that's not necessarily open source, but it's still free for people to use if you're not using it for like a commercial reason or something that people like. Oh yeah, so this was a finder ring that I made for Justin with FreeCAD. But so these holes, so some people actually 3D print the threads. I never do that. So what I do is I make a hole that's small, that's like close to the size that you'd drill before you thread it. I think I usually make it a little bit smaller. So I print it with the hole, then I drill the hole before you thread it, and then I use the tap and then to tap it. So that's what I would suggest. But some people 3D print threads, but I think they're crazy. So, but I don't know, whatever works for them. Oh, glue thread inserts. That's a good idea. Okay, yes. Okay, so this is OpenSCAD. And so this is like I was saying, where it's sort of like you have 3D print. You can make 3D models that are sort of like a computer program. So like here's the code to make this, and then here's the output. So, you could change. Here's the number of teeth, right? So this, and you could pick like if you want it to be XL teeth or not. The motor shaft, like how big the hole here is, and how high everything is, right? So, or the base diameter. So if I change this, say to like, I don't know, 30. Right? You could just change. You could change these, and then you quickly see what they are. So let's change the teeth, to like 50, right? And then see what it makes, right? So now I have a much bigger pulley, XL pulley here, And so, for example, the one where I put around my camera lens, I just have a big motor shaft, let's say like 45, or bigger. However, I measure it with some calipers and then set this to what I want, and print. And sometimes it takes me several prints to get what I want. I have to tweak it by like a few millimeters or something. But the blue is comments. You know, so it's like yeah. So they try to help you with the parameters, right? So you see profile, you know, three is XL, so it's for XL belts. Those are a type of pulley belts, and they have other belts too, like MXL. So if I just change this to 1, it'll change the teeth type, right?
Right. So all that is doing is just tells you what the parameters are, what the parameters.
Yep. This one is OpenSCAD. So FreeCAD actually knows how to use SCAD files. So you could technically do it in FreeCAD too. But I haven't bothered with that. I just used, for these ones where they already have the code for, I just used OpenSCAD. But you could mix, you can mix your parametric with SCAD stuff and go really fancy. But yeah, so yeah, what like Gary was saying, how when he was you're machining, you write G code. So when you make this model, you end up needing to put it in a slicer, which makes G code for you, which tells the 3D printer how to go. Yeah, so what I currently use to make the G code, which tells the machine, what to do, is I use Utilimaker Cura. So you could load one of the exports from FreeCAD or OpenSCAD or something that you downloaded, and then it makes it so the printer could do it. So there's a button here called Slice. You pick like your material that you want to use. Right now it's under generic PLA, right? So if I wanted to use generic PETG, right here, it ends up having like a bunch of different profiles based off the plastic you put in. So there's a lot of parameters. I wasn't planning to go through all like these settings and stuff, but there's lots of different settings like temperature, infill, speed, and stuff like that. And that's a lot of the work that you have to do to learn how to use a 3D printer. The what? I guess. But yeah, then you slice it and it tells you, this one's going to take 3 hours and 32 minutes, right? And then you could save it as G code and then put that on an SD card and put that in your printer and tell it to print that file. Like some of these things are nice to do. Like I notice, like I get better prints if I slow down the speed to 90% or whatever. So, or maybe I tweak the temperature a little bit based off the filament you're using. Like, the Cura tries to have specific filaments, based off what you buy. Like if you buy this, I don't know. I have a hard time reading what it's saying right now, but there's like a bunch of brands of filament on here, and it might have your particular brand, and that's just what Cura thinks would be good for theirs. I think they also kind of design it to try, to work really well with their own 3D printers, because the people that make this software actually sell their own 3D printers. Before I go into what other people did, does anyone have any questions what I talked about so far? So I was going to go through some cool astronomy projects that I found online. You'll notice that most of these projects are a combination of 3D printed objects and other materials, other hardware. Sometimes you need like acrylic to be laser cutted, or you need some machining work to be done. So I didn't pick projects that are just 100% 3D prints, but ones that utilize 3D prints. to make the project. So like here, I found several bath interferometers, which I guess are used to test the quality of your lenses. So that's kind of neat to buy your own. It looks like there's, I found actually 3 of these, and they usually include a list of stuff that you need besides the 3D printed parts, so that you could go and just buy it and put it all together with instructions. And a lot of these, you could build your own for, a lot of them are less than $100. I don't know how much you could buy one that's already made though, but I thought a lot of these are also for mirrors, but this one specifically says for mirrors. But I didn't read all the instructions, I don't know. But yeah, hopefully you can use it for both, I don't know. Have you used one? I don't know, it does look complicated, I don't know. Here's another one. Yeah, I don't know how to use them for mirrors or lenses, but I think it would be cool to try it out. You could test your new mirror when you get it back. So people have also used it to build telescopes. So like here's a 93 millimeter f8.6 telescope. And they just make it. So one of the things with 3D printers is your bed size. So you're usually limited to how big of a print that you can make. So sometimes you have to make, if you're using a lot of 3D printed parts that are big, you have to make them in pieces and you connect them together. Sometimes you make them so they interlock or they screw, they connect together some other way with glue, or you have other hardware to connect. So, there's no, you could see different sections using different plastics here. So it's not like the whole thing was printed in one go. That would be you need to use a really tall bed or a really tall 3D printer to print all that. So you could see in this one how, it's just several smaller pieces that eventually fit together and make the scope. So, I wouldn't say this is like a better quality than what you could buy. I think he does, if you know what you're doing, he ends up building it for like $50 though. So, but he already has a lot of the tools. If you counted the price of the 3D printer and stuff, you could always get a better, much better scope. But yeah, that one's small. So one of a really famous telescope build is this one, the Picon. So the tube isn't 3D printed, but all the other stuff is 3D printed. And it's a 6-inch, I think. Let's see. Oh, 4.5-inch reflector. So the mirror's not 3D printed, but the mirror holder's printed, the secondary holder, and they actually designed this that you hook up a camera up to this and get images out of it. But anyway, a lot of people have actually built this one. Just like a neat project to do if you have a 3D printer. But a lot of these projects, especially the ones that get really popular, you can actually buy the 3D printed parts from them. They'll usually set up a store and they'll be pretty cheap. So if you see a 3D printed part and it's a really big project, then odds are maybe there's a store and you can just buy the parts if you don't have a 3D printer from someone. But here's someone even made like a 3-inch daub, or 8-inch daub, I mean. The rods or whatever are not 3D printed, but a lot of the other stuff is 3D printed on there. I think the base is even 3D printed, yeah. So I'm not sure the bed size requirements. Some people just have crazy 3D printers, but I think this is still built in sections. Usually, this is a common website for people to post their 3D models that they design, the Thingiverse. And they usually just show you each of the 3D printed parts that are in the project. So you could see if maybe it's something you could build. This one has a lot of parts to print. Yeah, so, yeah, see, this is just only, so this, I think this is part of the base, or at least maybe it's part of the, one of the ends or whatever, right? And they're not printing the entire circle, they're only printing a quarter of it, and then you connect them all. So you could print it on smaller beds. Here's a go-to star tracker, actually. Mostly made out of 3D parts. There's some bearings and stuff to it. So this is kind of neat. The entire project's open source, all the electronics you need and parts and 3D models. And so you can put a camera on it and, you know, tell it where to go, and then it'll track so you can take long exposures. Thought that was a cool project. And then, of course, the focus masks, like I printed. So you could buy, so people have generators. But anyway, like, you could use generators to make those focus masks like I made. And then there's a bunch of eyepieces. You know, you could get oh, I saw this one. It's like a scope wedge. So here's a picture of it, I think used or put on. You know, he has a equatorial on a wedge for astrophotography. And this, oh yeah, and this is pretty crazy too. So, 3D printed Crawford focuser. So, I think this is quite a big build for this Crawford focuser, but there's a lot of small parts on this one. And oh yeah, this here's like, I think it's, yeah, a helical Crawford focuser. I think this one had like a video of it, and it's like super smooth. Let's see. Oh yeah. So obviously this tube is not 3D printed, but a lot of the structure is for this focuser. And then you could read a lot. There's a lot of cool stuff people have done. They don't necessarily share their models, but you could see what they did. And there's a lot of Cloudy Nights models, or Cloudy Nights forums about how people use 3D printers in their astronomy. You end up getting a lot of haters in these forums too. They're like, 3D printer could never do the precision of or whatever. But and a lot of that, you kind of agree to a lot of that. I mean, you kind of see their point or whatever. But I think it could be useful in a lot of places where you don't have like super high quality parts anyway, or you're printing something that just helps you. It's not really part of the part of the stuff that needs to be really of precision. But one thing also I was going to show was we were actually going to try to build this during this month's meeting, but Doug couldn't be here, is the low spec spectrograph, which you use a lot of 3D printed parts for. And so the low spec that we were going to try to put together is what I actually printed a lot of parts with using my printer for. So I don't know if we're doing it next month or what, but maybe eventually you'll see, how hopefully we can get this project put together. But there's a lot of cool websites about this project, and I was reading about it, and some people ask, like, why can't you just buy pre-made ones of these? And the amount of labor and stuff that you end up using, it looks like you could just buy some pre-made spectrograph for around the same price after you put in labor costs and stuff. But it should be a really cool, project that, just if you have the tools and know-how that you can put together and it works pretty well. Oh yeah, hard to get parts. So I'll post a lot of these links of cool projects that I found to the groups IO. All right, anyone have any questions? I know like there's some materials, I don't know if it's nylon, but that really can really eat up your printer head. So I don't know if that's the deal with nylon. A lot of the ones that are, a lot of it has to do with temperature. So what if we look up the temperature of nylon filament? So you have to print over 250 in a lot of nylon filaments. There's some that you can print at lower. Yes. And so the 3D printer I bought, originally it came with like a Teflon insert in the printer head, and that would start melting and outgassing and actually produce hazardous gases if I was trying to print at higher temperatures. So when I started doing more PETG and I wanted to experiment with higher temperatures, I had to replace that head because eventually that would be, melt away. And plus, I was always worried about the different, or the stuff that would get into air. That's why I don't print in ABS either. So PETG, I think, is fairly safe for printing, like if you have it in an enclosed space. Same with PLA, the starter plastic. But a lot of these other plastics, you have to be worried. I personally would worry about what kind of chemicals or stuff gets in the air when you're printing them. I don't know if it's nylon or not, but one of them like expels formaldehyde. Maybe it's that material you like to print with, that you make the Delron sometimes, or yeah, I think that like when you heat it up, it actually formaldehyde goes in the air, and that's probably not very good for you. So it's always good to know what material you're printing with. Yeah, there are 3D printers you could buy that have that are already in enclosures and that have ventilation systems with filtering. So ones that you could put it outside, or ones that just go through a carbon charcoal filter or something like that. Mine, the one I bought doesn't. So anyway, I hope this was an okay introduction to what you can do with a 3D printer in astronomy. That's about all I got. So from what I know, the problem with PETG and also a lot of other plastics is, especially after you open them, they'll get hydrated, which then causes them to not print as well. So you could store them with some desiccant and probably in a Mylar bag to try to prevent that. But you could also dehydrate it before you use it if you know you're going to use it. So you could do it with like a food dehydrator, or if you have a vacuum chamber, that's even the better way. If you dehydrate it using heat, every time you do it, it kind of degrades PETG again. If you had a vacuum dehydrator, then you don't have to worry about that as much. So what I've been doing is I have the food dehydrator, and I just put it in at the recommended temperature for that material, or like, I don't know, 12 hours or something before I'm going to use it. Like if it's one that's already been opened. A lot of these, when you buy them, they're really pretty much in a vacuum sealed bag already, and they should be pretty good until you open it. But after I open it, if I haven't used it for a while, and I know like, hey, I have a print coming, then I'll dehydrate it ahead of time. Yeah, I mean, sometimes I'm just like, I just opened a bag and, I made a big print and I'm just like, okay, what other stuff could I print while this is still good so that I don't have to dehydrate this again? Sure. So the question was about shrink factor for PETG. So I haven't noticed very much any shrink factor with PETG. With PLA, originally I had a little bit, like 1%, 2%. With PETG, it has usually been pretty darn close where I had to take a model and then just say like, make it 3% bigger or something like that. It's usually, I design it and I print in PETG and it stays pretty much where I wanted it to be. Yeah, that's my guess. So like for me, PETG seems like the ultimate material for me to use. I'm really glad, it doesn't, as far as I know, there's no bad gas that comes out from heating it. It lasts, I could have it in the car and it won't warp and it doesn't really shrink. The only downside might be that if you don't have your settings right, it makes strings, it could be more stringy compared to other materials. But once I have all the parameters set and like the correct feed rates, I haven't had very much stringing. So it's been a really good material for me.